Hi everyone. Today we're going to be going over Advent Code 2023, Day 2, looking at a solution in Python. So let's get right into it. Looking at the problem, basically we're dealing with a game that the alpha is playing with us, where in each one of these games we have a bag full of cubes, of red, blue, and green cubes. And each one of these statements separated by a semicolon is like one round of the game, where the elf will draw a handful of cubes out. So for this example, in this round, the elf drew 3 blue and 4 red cubes out. Then puts them all back in, draws 1 red and 2 green, and 6 blue, puts them all back in, and draws 2 green. And basically what we want to do is, with the knowledge that there are only 12 red cubes, 13 green cubes, and 14 blue cubes, we want to see which of these games are possible. So we can see that the approach is basically going to be determining if the maximum number of cubes drawn for each color is greater than these values supplied here. So for example, here, the maximum number of red cubes we draw is 4, which is less than 12. For green, we only draw 2 at most 2, less than 13. Similarly, only draw at most 6 blue, which is less than 14. But for this example, game 3, you can see that in this first round, we draw 20 red cubes, so this would not be possible if there were only 12. All right, let's look at how to code this up. So here is my solution. This contains code for part 1 and part 2, but we can start by looking at just the code for part 1. So first, set up a dictionary containing the limits for each one of the number of colored cubes, just so that we avoid putting in any magic values later. Then I take the input file from the command line as a command line argument and read those lines. Now I simply iterate over each one of the lines and use regular expressions. It's also possible to just call string.split a bunch of times, but I thought this was a little bit cleaner. So here we get the number for each game using this regular expression, where we basically take out this like capture group is looking at the number of the game, where like this escape D is looking for a digit, and then the plus sign means we're matching more than one. Then we validate, make sure that we actually got a match, and then set the game number to this game number variable. Now what we'll do is look at so there's a little bit of code part 2 in here too, but essentially what we're doing is looping over this color limits dictionary, which, to remind you, has the key as the color and the value as the maximum number. And what we're doing is essentially using a second regular expression and finding the color count for each instance of the color. So what this will return is, if we're on like the first iteration of this loop, the color is red and the limit is 12, that'll return this and this. Then when we have blue, for example, we'll return a list including this digit and this digit, and then for green, similarly, this and this. Then we can look at what's the maximum over these color counts, and if it's greater than the limit for this color, this is not a valid game. Then we're doing some extra stuff for part 2, which we'll talk about in a minute. Finally, if it's a valid game, we just want to sum over the game numbers. Then we can print out our solution. Let's run that example case, get a value of 8, which is indeed correct. All right, we can move on to part 2. Now for part 2, the elf poses a little bit of a different question, where rather than telling us the limit for the number of cubes, we have to determine the limit for each game, or the minimum number of each one of the color cubes in the bag. So essentially what we have to do is we're still getting a list of the number of cubes over each round for each color. So, but instead of finding the maximum and checking if that's greater than the limit, we know that the lowest possible limit that'll allow this game is if we have a number of red cubes equal to the maximum over each of the rounds. So for example, since we have 4 red and then 1 red in the next round, we would need at least 4 red cubes. And similarly for blue, we have 3 and 6, we would need at least 6. And then for green, we have 2 and 2, so we'd need at least 2. Then what we do once we have these limits is simply multiply the values for red, green, and blue together, and then sum that over each of the games to get our solution. So let's look back at the code. So now what we're doing is initializing this second variable to store the total for part 2, and then within the for loop, this color product will store the product of the 3 color limits as we iterate over the 3 colors. So we'll now use this this max count value a second time, because we know that this max count is going to be the lowest possible valid number, which is for the number of color cubes, which is what we're looking for. So we're simply multiplying our color product by that value for each one of these, for each one of the 3 colors. And since we initialize color product with a value of 1 here, we'll essentially have like 1 times the limit for color red times the limit for color blue times the limit for color green. Or we can just drop that 1 and we have the color product. Then we're no longer caring if this is a valid game. And so we're simply adding to the part 2 total. Here we have looks like we have a solution for 2286, which is indeed correct. So that was day 2. Thanks for watching. Let me know if you have any questions or comments, and I'll try and address those in the comment section. Thanks.